Space is full of mysteries waiting to be uncovered. Some of them are enormous planet stars, entire galaxies, but others hide in plain sight, smaller, fainter, overlooked for centuries. For more than 200 years, Vesta and Ceres were just points of light in the asteroid belt, invisible to all but the most powerful telescopes. Then came a spacecraft unlike any before it, a mission that would take us closer than ever to these ancient worlds and reveal stories billions of years in the making. Today, let's retrace the journey of NASA's Dawn probe and discover what it taught us about the forgotten giants of the asteroid belt. In the early 19th century, astronomers discovered something that would reshape our understanding of the solar system. In 1801, Giuseppe Piazzi found Ceres, the first asteroid ever recorded, and at the time it was even added to the list of planets. Soon after, Pallas, Juno and Vesta followed. For a brief moment in history, our solar system had 11 planets, but as more and more asteroids were identified, it became clear we could not keep expanding the planetary list forever. Millions of rocky bodies populate the asteroid belt, scattered across vast distances. Yet for more than 2 centuries, these giants of the asteroid belt were nothing more than distant specks of light. Then in 2011, everything changed. For the first time, humanity would see 2 of these ancient worlds up close. The key to this breakthrough was NASA's Dawn spacecraft, launched in 2007 with an ambitious mission to explore both Vesta and Ceres. What made Dawn truly extraordinary was its method of travel. Unlike chemical rockets that rely on explosive reactions, Dawn used an ion engine. Imagine a car that accelerates painfully slowly but never stops running day and night for years, while chemical thrusters burn bright and quick. Ion engines ionize xenon gas with electricity releasing particles at 150,000 kilometers per hour. The thrust is gentle, so gentle it would take 4 days to reach highway speed, but over time it adds up. This efficiency allowed Dawn to do what no spacecraft had ever achieved: enter orbit around not 1 but 2 extraterrestrial bodies. For the first time, we could embark on a comparative study of 2 ancient worlds within the asteroid belt. In July 2011, Dawn arrived at Vesta, and the images it returned stunned the scientific community. At first glance, Vesta looks like a squash ball, scarred and uneven. With a diameter of just 500 kilometers, it is too small to be fully rounded by its own gravity. To put this in perspective, its surface area is about the size of Pakistan. Yet despite its modest size, Vesta makes up nearly 9% of the total mass of the asteroid belt. But the most striking feature of Vesta is at its south pole. Billions of years ago, 2 colossal impacts reshaped the asteroid, leaving behind the vast crater known as Rhea Silvia. Its central peak rises 20 to 25 kilometers high, once thought to be the tallest mountain in the solar system. Compared to Vesta's small size, it looks like a colossal scar visible even from orbit. These impacts blasted enormous amounts of debris into space, giving rise to a special class of objects called V-type asteroids. Many of these fragments eventually made their way to Earth. In fact, about 5% of the meteorites found here originated from Vesta, meaning pieces of this world are already within our reach. So why is Vesta so important? Because it is a protoplanet, a planetary embryo that never completed its formation. Billions of years ago, countless planetesimals collided and merged to build the large planets we know today. Vesta began that journey. Evidence shows it once had a molten mantle and still retains an iron core, much like Earth or Mars. Yet Vesta stalled in its growth. One possible culprit, Jupiter. The giant planet's immense gravity likely disturbed the material around Vesta, stealing or scattering the mass it would have needed to become a full planet. Vesta's surface holds even more surprises. Dawn captured false color images revealing a patchwork of materials, dark deposits from ancient impacts, and red regions where rock melted and resolidified. Scientists also observed signs of mysterious flows across craters, perhaps created when impact heat briefly liquefied materials. In one of its youngest craters, Marcia Dawn found something unexpected: pitted terrain previously only seen on Mars. These small depressions may have formed when water locked inside rocks was suddenly released as gas exploding outward and leaving behind clusters of pits. Perhaps the most charming discovery was the Snowman, a chain of 3 connected craters near the equator. But beyond its whimsical appearance, this formation records the violent bombardments that shaped Vesta's surface over eons. For 1 year, Dawn orbited Vesta, peeling back the layers of its story, and then it was time to move on. After leaving Vesta, Dawn fired its ion thrusters once again, slowly but steadily, escaping the asteroid's gravity. For 2 years, it crossed the emptiness of space, heading toward the largest object in the asteroid belt series. Before Dawn's arrival, the best images of Ceres came from the Hubble Space Telescope, where it appeared as nothing more than a blurred disk. But as Dawn drew closer, something extraordinary came into view: bright white spots gleaming on its surface. What were they? Ice salt, or something stranger? The mystery captured global attention. Ceres is not like the other asteroids. It is more akin to a frozen world. Beneath its rocky crust lies water mud and possibly a briny mantle. Its density suggests that up to half its volume may be water, making it one of the wettest worlds in the inner solar system. The bright spots turned out to be deposits of salt left behind by cryovolcanoes. Unlike fiery volcanoes on Earth, cryovolcanoes erupt salty water that quickly sublimates in the vacuum of space, leaving behind brilliant reflective patches. These spots fade over time under the sun's radiation, which means the ones we see today are relatively young and possibly still active. Some craters near the poles, locked in eternal shadow, even preserve water ice that has remained frozen for billions of years, untouched by sunlight, very much like the ice trapped at the lunar poles. Ceres is a world scarred by countless impacts, but its surface tells a story of renewal. Dawn observed craters with collapsed walls, central peaks and ridges, showing that the crust has shifted and evolved. It also found long fractures and troughs, evidence of stresses pulling and compressing the surface. Among the most puzzling features is Ahuna Mons, a mountain 20 kilometres wide and 5 kilometres tall. It rises alone, with no other features like it nearby. Scientists believe it may be the remnant of a massive cryovolcano triggered by seismic waves from an ancient impact on the opposite side of the dwarf planet. By 2018, Dawn had completed its mission. Its fuel reserves were finally exhausted, leaving it unable to maintain communication with Earth. Today, it remains in a silent, stable orbit around Ceres, destined to drift there for decades, a monument to human ingenuity. But Dawn's story didn't end with silence. Its discoveries transformed our understanding of small worlds in the solar system. We now know that Vesta is a surviving protoplanet, and Ceres is a watery dwarf planet with evidence of ongoing geological activity. And perhaps just as important, Dawn proved the power of ion propulsion. This technology is now used in missions like ESA's Bepi Colombo, heading to Mercury, NASA's DART, that tested asteroid deflection. And even in thousands of Starlink satellites orbiting Earth, the quiet blue glow of ion thrusters may well be the future of space exploration. The Dawn mission was more than just an exploration of 2 distant worlds. It was a journey into our past, showing us the building blocks of planets and the hidden reservoirs of water that may shape their evolution. We began with tiny specks of light and ended with breathtaking views of mountains, craters, and bright volcanic scars. Vesta and Ceres are no longer just names in astronomy. They are worlds with character, history, and secrets. So the next time you look up at the night sky, remember, some of the faintest points of light may hold stories as grand as any planet, And thanks to missions like Dawn, we're only just beginning to uncover them. The story of Dawn reminds us that even the smallest worlds can hold the biggest secrets. Vesta revealed the scars of ancient battles, fragments of its body scattered across the solar system, some even landing here on Earth. Ceres showed us a world rich with water, and still alive, with mysterious activity, reshaping itself in ways we never imagined. These are not just rocks drifting in space, they are witnesses to the birth of planet survivors from an era when our solar system was still young and chaotic. And thanks to Dawn, we can now see them not as distant specks, but as worlds, with depth, history and wonder. Our exploration of the universe is only beginning. Who knows what stories the next mission will tell, or what secrets are waiting beyond the asteroid belt? One thing is certain, as long as we keep looking upward, there will always be more to discover.